So we said that adding elements to the front. So let's write our list. So here we have a list. We have our head and our size. And our list is pointing at a node, which is pointed to another node, which is pointed to another node, and so on. Okay, so there's one node, the last node is pointing at null. So if we want to add a node to the end, we're going to have to declare a list node the same way as before. The only thing that differs here is that we're going to add the node not to the very first place, but to the very last place. Okay, so we're going to have to create a temporary pointer here that will iterate through the list until it reaches the address of the last node. Now when this iterator, this pointer, knows the address of the last node, then it'll connect the newly created node to it. Okay? So our algorithm should look something like this. So first of all, we're going to create our node. Okay? Then we're going to fill our node, our list node. Now that we have our node filled, we have to place it at correct place. So we're going to create a temporary pointer. Let's call that pointer P. Now P initially starts pointing at the head of the list, and then it'll keep moving forward so until we reach an element that has its next null. So while P next is different to null, we're going to increment P. So P takes its next. And finally, once we reach to the last node, we have to disconnect to it. So the last node that at address P, so its next will be the newly created node. So that's node. And basically that's it. That's basically what we have to do. That's our basic algorithm. So let's implement the idea using the C language. So we're going to create a function called pushback. So void pushback list. We're going to give it a list pointer L and a value. And of course, we're going to create the node the same way and fill its value the same way. And its next will take null because we're going to add this node to the very last of the list, which means that its next must be null. So ln next is null. Okay? Now we have to create a list node pointer. So that's a list node pointer. We called that pointer P. P will start at address head, and we're going to keep incrementing P until P next becomes null. So while P next is different to null, P takes its next. Okay? There's here one counter example. There's here one particular case where our list doesn't have a single element, where our list is empty. In that scenario, we cannot access, if the list, if P points at null, it means that it doesn't have something called next. So this would generate an error. So we have to compare here. So if while p is different to null, and p next is different to null. So if the next element is different to null, or p itself is different and p itself is different to null, then we have to work. If p is null, then we have to quit. We have not to do any instruction because that would generate an error. Okay? So we're going to have to link to the next of p. So we're going to put inside the next of p the ln list node. And basically that's what we need to do. And of course we're going to have to increment the size, so the size gets incremented. And we have our node pretty much connected the way we wanted it to be connected. Now here, if the head is pointing at null, if the list is empty, then basically we're going to have to connect the element directly to the L head. So if p equals null, then basically L head takes that ln pointer. Otherwise, we're going to do the following. Okay, and that should do the job. So let's make sure that there's no problem in compilation. And here, instead of push in front, let's change that with back. And as you can see, the order is now correct. So that's 5, 3, and then 8, because now we're dealing with the list as if we're dealing with a queue. So we're adding to the back, and then we're popping from the front. Okay? So that looks like a queue. Now let's do the same thing here, but instead of pushing to the back, we're going to pop from the back. So popping from the back is basically the same thing. We're going to have to iterate. We're going to have to iterate through the list. So we're going to have to create a pointer here. We're going to iterate until we find the last element. Okay? And we're going to have to make the element just before the last one points to null and free the last element. Okay? And of course, we're going to have to save its value there inside the value variable. So let's write that idea. So here we have an integer function called pop back list, which takes a list pointer L, and it tests if the list is empty. Then it basically is going to print an error message. And then we're going to create a value here. So value takes L head, and well, basically we're still not in a position to read the value because we have to iterate till we reach the very last element. So here's what we're going to say here. So if the list has only one element inside it, it means that we have to read that element and just return. Okay? So if the list is empty, we just return. If the list has one element, how do we know whether the list has one element or not? We just check whether the lnext equals the lhead next equals null or not. If the next of the list node that the head is pointing at is null, it means that there's only one node inside the list. In that case, we're just going to declare a value variable of type integer, and it'll take the L head value, and then we're going to free the L head, and the L head would take null, and then we're going to return that value. Otherwise, if the list has more than one element, then we have to create an iterator, a pointer, that will point to the, not the very last element, but the element just before that. Okay? So the list node, we're going to create a list node pointer p, let's call that ln, equals the L head. And we're going to iterate through the list, starting from the very first node to the very last node minus one node, so the very last, not the very last, the element just before the very last node. So we're going to iterate till that, and after that we're going to connect that node with null, and we're going to extract the value, and then we're going to return it. So let's do that. So while ln next is different to null, then basically we're going to have to increment ln. So ln takes ln next. Now we kept iterating until we reached the element just before the last element. So we reached this element because the next of this node here is this node. And the next of this node here is this null here. So we know that we are at the last node minus one, okay? So we are on top of this node here. So we said that we're gonna copy the value of its next. So let's do that. So int value equals ln next value, and we're going to free that. So we're going to free the ln next, and then the ln next takes 0, and finally we're going to have to return the value. And let's test whether the function is working correctly or not. So we're going to start popping from the back of the list. So let's do that. So there's an error here. We missed something. We basically have missed decreasing the size of the node. So L size gets decremented by 1. And here, of course, the L size also gets decremented by 1. So let's see that. And as you can see, there's no error there. So basically, that's 8, 3, and 5. So the order again got flipped again because we are pushing to the back and then popping from the back. So the place we're pushing to, we're popping from. So that's just like a stack. Okay. So again, you can use linked list as a stack, as a queue. So they are more general way of linked structures. For that reason, they're so important, okay, to master. So again, you're gonna find a handful of problems related to linked lists inside the problem set, I really encourage you to dig in them and try to solve them by your own. Just get your hand dirty with the code, try different stuff, try to even come up with problems yourself, try to solve them. And if you could not, then please make sure to ask questions. Make sure to comment if you have anything that is not clear. Make sure to mention that. And of course, I'm going to publish. You're going to find videos of the correction of all the data, structure problem set correction. So make sure that you check them out after completing the problem statements yourself. But of course, make sure that you try on your own before seeing how I did it, because that's the best way to learn. Just take a piece of paper, a white piece of paper, and try making diagrams, making connection, try connecting stuff, fire up the debugger, see what is going on with your code, why it doesn't work, and start seeing instruction per instruction. Believe me, the things that you're going to learn in the process are far more than the stuff that you're learning, okay, itself. Okay, so sometimes you don't understand something, so you make a search, and the information, a lot of information you're going to learn that are more important than the stuff that you're looking for in the first place. So make sure to get your hand dirty, try different stuff, and that would be really helpful throughout your curriculum and your journey. So thanks again for watching, and see you at the next video.